for 2929, we have a conducting rod AB shown in the figure. It makes contact with a metal rail CA and DB. The apparatus is in a uniform magnetic field of 0.8 teslas. A is asking, find the magnitude of the EMF induced in the rod when it is moving towards the right with a speed of 7.5 meters per second. So we're given the length, magnetic field, and velocity. So we know to use EMF equals BLV, and we plug all of our values in, and then you'll get your answer. B is asking, what direction does the current flow in the rod? Since the magnetic field is pointing into the page, using Lenz's law, we know that the induced has to point out of the page, and with the right hand rule, we know that for it to point out, it needs to be counterclockwise. C is asking, if the resistance of the current ABDC is 1.5 ohms, assumed to be constant, find the magnitude of the force required to keep the rod moving to the right with a constant speed of 7.5 meters per second. Ignore friction. So EMF and force are correlated through using the equation EMF equals IR. We relate our current to EMF with Ohm's law. The force on the rod is equal to F equals ILB times sine theta. We solve for our I and plug into the force equation, and now we have every variable we need to plug it all, and we plug them all in, which gives us 0.8 newtons to the right. D is asking, find the direction of the force required to keep the rod moving to the right with a constant speed of 7.5 meters per second. To keep the rod in a rightward motion, the direction of the added force must be to the right.